Welcome to my video for L'Hopital's rule. I will be going through L'Hopital's rule, doing an example here, and then I'll do some follow-up videos with some other examples. So what L'Hopital's rule is it's a way of doing limits for indeterminate forms. And an indeterminate form, we'll be going through that. In fact, let's go ahead and get started with this. If f of x and g of x approach 0, as x approaches a, then the limit as x approaches a of f of x over g of x would be approaching 0 over 0, which is called an indeterminate form. So when you have a limit written in this indeterminate form, you can use L'Hopital's rule. What L'Hopital's rule says to do is to take the limit of the numerator and take the limit of the denominator separately, and the limit of that is equal to the original limit. So you can see that the limit of f of x over g of x is equal to the limit of f prime of x over g prime of x. All right, so that's one indeterminate form. Other indeterminate forms include infinity over infinity, infinity times 0, infinity minus infinity, 1 raised to the infinity, 0 raised to the 0, and infinity raised to the 0. Each of those are different indeterminate forms that require slightly different techniques to work with, but for most part they're either rewritten as the form of 0 over 0 over or infinity over infinity. All right, let's go ahead right into an example here. So this is the first example. You say we're taking the limit of square root of 4 plus x minus 2 over x as x approaches 0. And what we'd normally do, if we didn't have L'Hopital's rule, which you might have done in the past, is we'd multiply through by the conjugate, multiplying by square root of 4 plus x plus 2 over square root of 4 plus x plus 2, and then hopefully we'd be able to simplify things and take the limit from there. Let's see if this is indeed an indeterminate form. So when we plug in 0, we end up with the top being, get the right color here, we end up with the top being square root of 4 minus 2 over 0, which is equal to 0 over 0. Okay, let's clean that up a little bit. And so that is indeed an indeterminate form, so we can use L'Hopital's rule. And I always just abbreviate it as LH, L apostrophe H, for L'Hopital's rule. I just use that to show that's what I'm doing. So we're going to take the derivative of the top and the derivative of the bottom separately. So to take the derivative of the top, I'm going to rewrite this thing, limit as x approaches 0, of 4 plus x to the 1/2 minus 2 over x. And so now when we take that derivative, the derivative would be 1/2 of 4 plus x raised to the negative 1/2 times the derivative of what's inside, which is just 1. The derivative of the minus 2 would be 0 over the derivative of x is 1. So the limit notation carries through. And then we can rewrite that one more time. Clean that up to be, so this is a negative 1/2 power, so that's going to go to the denominator. The 1/2 will give us a 2 in the denominator. So we end up with 1 in the numerator. The bottom ends up being 2 times the square root of 4 plus x. Sorry, my plus looks a little awkward there. And still taking the limit as x approaches 0. And as we can now plug in 0, we'll get 1 over 2 times the square root of 4. That's 1 over 2 times 2, or 1/4. So that's our answer. We'd get the same thing by multiplying through by the conjugate. This is just another way of doing it. But in some cases, L'Hopital's rule is the only way. All right, thanks for listening to this. There'll be a follow-up video or two doing some more examples of how to use L'Hopital's rule.